a brief introduction of myself. My name is Solan Das. I work with ABN Bev as a data engineer. Here, I'm leading the generative AI capability on the data engineering side, mostly working on Azure tech stack like Databricks, ADLS Gen 2 for storage level purposes, and also ADF for orchestrations. So yeah, Colin, you can go ahead with your introduction. Just brief me about the projects that you have worked on. What are the tech stacks you have used? Which companies you have worked for? What were the challenges that you faced in these projects, and how you solved them?
I'm Ankit Raj. I'm having 2.5 years of experience as a Azure data engineer. Currently, I'm employed at 𝐭𝐞𝐫. In my current role, I'm actively engaged in a North American insurance-based project. In this project, I have been a key part of a team that handle data processing tasks. So my main job is to make sure that data moves smoothly through the systems, and we use Azure Data Factory and Azure Databricks to extract the data from source, and after some transformation, loaded it into the Azure Synapse Analytics at the end. And also, I've done some certifications like Data Engineering Associate, DB203, and AZ900. And in my project, I can say that I have developed data integration applications which mainly focused on SAT Type 2 data, and also that I have been responsible for implementing transformations and loading of data to successive layer using Azure Data Factory as an orchestration tool.
Okay. So can you go ahead and explain one business use case that you solved for? Like, what was the requirement of the business? Like, requirement in the sense, not functional requirement, but what did the business want and what did you solve for? And how did you contribute to that?
Actually, in our project, basically, data is present on on-premise side, and we extract the data using Azure Data Factory and loaded it into a predefined layer, which is Azure Blob Storage. And after that, we need to do some transformations like handling missing values and like handling with null values.
Yeah, that I understand.
Yeah.
Why did you do it? Like, I
after
understand you extracted data from a data source which was on-prem. You got the data to Azure cloud storages. You did some pipelines on Data Factory and wrote some transformations on Databricks, right?
Yeah.
Yeah, but what was the purpose of doing all these things?
The
Like,
main
what
purpose
did you
of
solve
doing
for?
this transformation is to generate the credit score at the end, because the data it is a bank, like a data from a bank. So the main business use case is to update their credit score so that the bank contact to their customer and provide the benefits to their customers on the basis of their credit score. So after that, during transformation, we need to add some surrogate key, and after that, on the basis of their track record, their financial stability, and their previous loan status, at the end we generate their credit score, and after that we load the data into Azure Synapse Analytics for the Power BI team, and they finally analyze the data.
So let's talk more about the data. As you say, this is banking data, right?
Yeah.
This is banking data. You said credit score, right? This data had credit score for each customer, I suppose, right? So mostly this data would be having, personal information of a customer, right? Like his location of where he is living, might be his contact details, might be his email addresses, might be his occupation, right? So, and also like, identification details like your Aadhaar card, PAN card, which is actually most important to kind of derive any kind of credit score or credit history for that matter, right? So were you doing any kind of data masking on top of it? Because as I understand, Aadhaar, PAN, these are personal details, right? Should not be exposed to any dashboards or systems or for any business purposes. So where was there any data masking that you were doing or a hash
Yeah,
key masking that you were doing?
data masking is very important in this case. Mostly in our team, like after like the other team put the data into firstly when we extract the data from one frame size to Azure Blob Storage, then a particular team works on masking and all that, and they after doing the required transformation, they move the data into the next layer, and we took data from that layer up and do the required
Okay.
transformation according to the instruction given by the Power BI team. And then after the required transformation, we loaded the data into the Azure Synapse Analytics.
Okay, got it, got it. How many data layers are present in your project specifically? Like you said, you read data, like your consuming level and producing level was confined to one layer, right? You consume data in one layer and you produce to another layer. So how many layers was it before that and after that? Like who all came
Totally,
in process?
like totally, there are three layers. Firstly, the first one is predefined layer, in which data was initially present, and a team working on the data and do some masking and all that. And after that, they put the data into the landing layer, and we extract the data from landing layer and do necessary transformation and put it into the next layer. And after that, after that, if there is if I will if any the Power BI team instruct us for the aggregation, then we do the aggregation and the put it in, directly into the Azure Synapse Analytics.
Okay. And what does Azure Synapse Analytics do? What is the role of Synapse here?
Basically, Synapse is used, Azure Synapse Analytics is used by the Power BI team for the analytical purposes. I think it determines both the data warehousing and the data analytics. Like it works well with both the things. It is good for data warehousing and big data analytics.
Okay. Okay. So you will be using delta tables, right? As you're using Databricks.
Yeah.
Right. So can you tell me, okay, let's first start with tell me like certain features that Delta Lake provides, which other data lakes or other RDBMS fail to do.
While creating the data table, along with the table, we get a extra file, data log file, which keep track of all the records, what modification and transformation, uh, like what all the transformation has been done is recorded in the JSON file of data log.
Okay. Is the transformation recorded or the data snapshot is recorded?
No, the transformation is recorded. Like the
Okay.
details of
So
transformation is recorded.
in the JSON file, you're saying.
Yeah.
So if we are, so suppose you made a transformation. Suppose you have a data set called orders data set and you did a group by on it, and then you did a certain level of windowing functions on it, and you did not write the data. So and suppose you wrote the data also, and then only like if you write the data, I guess the .json file will be created, right?
Yeah.
So is there a possibility of going back to the transformations, like not to the original data, but two steps back to the transformations?
No.
No, right? So then
Uh,
it does not save transformations, right? So what it saves is history of the data that you write, right? It does not save each and every transformations that you do, because if it was able to do that, then probably you would able to time travel through stepwise transformations also, which particularly we are not able to do in Databricks, right? We can only go back to the snapshots that are written on the disk on the delta table. Suppose yesterday you write a data set and today you write a data set. So you can go back to the previous timestamp where you have written the data set, but not the intermediary transformations as such. Okay, no issue. How do we ensure asset transactions? Like asset transactions is also a feature in Delta table, right?
yeah,
Like
Deepak.
it supports asset transaction. So what is asset transaction and how does delta table ensures that?
Like in ASIC transaction, basically, like we can say that it provides the atomicity and consistency, integrity, and the durability of the table. Like after a transaction is completed, it will be there in the database. Whatever may come in between, it does not affect the table. So. So mainly for analytical purpose, we use delta table because we can do the required transformations in the delta table. We can update it, insert a few records in it, and we can merge two tables on the basis of our requirement. We can merge two tables for our analytical purposes.
Okay, okay. You said integrity, but so just a feedback here, it's not integrity, it's isolation. Okay.
Yeah, sorry, I should.
So your delta table ensures that your tables and views are isolated from each other so that one transaction is not visible to the other.
Yeah.
Okay. Have you heard about Z ordering?
Yeah, jet ordering is a feature which optimize. Like I have not used it much in my project, but I know that
Mhm.
it optimizes the performance of our query.
Of your
Of our
query.
query, yeah.
And how does it does do that?
Like in the I don't know how in the background how it works, but it do the like we can use it as a performance tuner. Like it optimizes the performance of our job.
Okay. Okay. On a general, not Databricks level, but on a general Spark level, what are the other performance optimization? Do you know? Like, what are the performance optimization tuning activities that I can do? Suppose there is a notebook that is running on Databricks and it's
Okay.
getting out of memory error, or it's suffering from a huge time latency that you are seeing on a daily basis, and you have to run a ETL pipeline on a daily basis, which should not take so much of time because the other teams have to work on it, and latency is a huge issue there. Okay, and sometimes with this latency, it also goes uh, like serve have out of memory errors. So how do you solve this, and what are the steps that you would take to do it?
We usually get out of memory error due to the unordered distribution of the unordered distribution of data across the partitions. So, when for resolving this issue, we can enable adaptive query optimizations. For that, we can enable AQE, which can dynamically coalescing the shuffle partitions, and after that, it will resolve the issue of out of memory error.
I mean, that is already enabled in Spark 3, right? It's
Yeah.
automatically enabled. So, I mean, still you are facing out of memory and partitioning skewing is happening. So, how would you investigate the issue? Because see, AQA is something that was not enabled inherently in Spark 2, but right now as we use Spark 3, your AQE is already enabled, right? Like inherently it's enabled. Like whenever you write code, will go through the optimal query plan and it will try to do it. But still, as you have, suppose, a million rows or a billion rows, you do face on a daily basis, you do face lags and latency issues.
Yeah, for that we can particularly visualize through the Databricks UI and suppose like a particular partition. If we face out of memory error due to a particular partition, then we can repartition our data and we can repartition our data or coalescing our data manually. Like after and also we do some more transformations like caching and we use caching and process to avoid decomputation of the same data, decomputation of the same data frame.
Okay. So which is better, repartition or coalesce?
Coalesce is better, but we have an advantage with the repartition. Like it can also increase the number of partitions.
Yeah, no, suppose you want to decrease the partition only, so coalesce is better, you said.
Coalesce is
And
better.
why is it so?
Because internally it takes lesser time to decrease number of partition with comparison to repartition.
Why?
Because I'm not much aware of this, but in case of repartition,
okay.
The system has to analyze the previous number of partitions, and after that it decides whether to partition it more number of times or lesser number of times. And in case of collision, system in the background system has decided that system by default understood that it has to decrease the number of support partitions.
Yeah, I mean, the brief answer would be shuffling. Okay, so yeah. Coalesce does not shuffle the data. Repartition shuffles the data. That's why coalesce is faster. Okay. So can you explain me the memory management in Spark? Like, how does Spark manage memory or allocate memory? Like in a very brief way.
For memory management, like fixed memory is assigned to a fixed memory is assigned for the Spark application, and a part of memory is also assigned for off-heap memory, and the rest of all, like 60% of memory is assigned for the storage and computation. Both storage and computation together occupy the 60% of memory, and Spark applications internally sometimes when computation need much memory, then it scale up part of the storage memory and give it to the execution memory.
Okay. Another 40%?
And another 40% is divided across the off-heap memory and off-heap memory and the Spark memory.
No. So the 40% goes towards user memory. So the off-heap memory you already told, right? So your 300 MB is your reserved memory. Then comes 384 MB, which is your off-heap memory or your overhead memory that you get. 60% out of 100%, your 60% goes to unified memory, which is the storage and execution, and your 40% goes towards user memory. Okay, no issue. Okay, so in your project, obviously you should be doing CI/CD, right? Like, so can you explain me the process where you as a developer come in, you work on a feature. So how does the process of you pushing code to Git works? how do you contribute to the project, like not on a project level but obviously on your code base level, like how do you contribute to Git, and what are the following processes that happen to build, test, and deploy the packages?
Actually, I have not used this CI/CD in my project by myself. Currently, I'm learning it, and I'm unable to answer this question.
Okay, no problem. Okay, shall we move on? Shall we move on to certain coding questions?
Yes, sure.
Sure. Okay. You can share your screen with the docs link. I will paste the question there. So, okay, this is your question. Okay. So you have one transaction table. Okay. So this transaction table has columns like user ID, spend, transaction date. Okay. And you have certain IDs, spends in numeric format, date is a timestamp. Okay. So so assume you are given a table below for Uber transactions made by users. So your aim is to write a query to, you have to find out, you have to obtain the third transaction of every user. Okay, so suppose, for example, 111, the user ID 111, if you see have occurred 3 times. So the third transaction you have to find of the user 111. So similarly, it's just one example. Similarly, 145 can also occur like 6 times, or any other user ID could appear like multiple times. So you have to find out multiple IDs. Here in the example output, 111 is there, but here that could be like two or three rows also, where you have to find out for each user transaction what was the third transaction, and you basically print all the details that are there: user ID, spend, and transaction date.
Okay.
Yeah, so you can start. And if you are doing like step by step, you can let me know the output that will come out after each step. Okay.
Okay. Yeah, I think it will work. Here in the query, I have used a window function row number for the partitioning the data uh, with this column user ID, and at the end I have applied a filter condition where it every time it extracts the third record from each user ID.
Okay, okay, so before your query is there, type in the output for the subquery. Like how will the output look for the subquery? So when you have row number over partition by user ID, order by transaction date, create that table out.
Then the output of a nested query will be like this.
Scroll little up. I cannot see actually. Yeah, sorry. So this would be the third transaction.
And here it will be the third transaction.
And you're selecting where your count is 3.
Yeah. Similarly, for the user ID 121 and 145, it will work the same way.
Okay. So suppose, I mean, this is correct as per the table given and the logic given. Your output is correct. But here, instead of using row number, you could have used dense rank. Why? Because suppose the transaction date here is not a timestamp, right? Suppose it's a date without the timestamp. So a user could have multiple transactions, right? For a single date. So in that sense, his third transaction won't be calculated in that. I mean, his third transaction could be in the similar day. So all those multiple records should come as his third transaction, right? So in that sense, a dense rank function would give the record the same rank. I mean, in that sense, row number will go like 1, 2, 3, 4, right? But your dense rank would repeat itself.
Yeah, it will repeat.
Yeah, I mean, it's just a optimization. Like you can use dense rank here, but again, according to the table given, a row number is perfectly fine. Nice. So let's move on to the next question. I pasted. Just a minute. So your question is write a SQL query to calculate the cumulative sum of sales amount of each product ID ordered by sales date. Okay. However, the cumulative sum should reset to 0 whenever a new product ID is encountered. So like for each product ID, you have to find the cumulative sum. That's the whole point. Let me also give you the table so that it's clear. Okay. So these are your sales, like your transaction ID. I'm in the first column here. Let me write it down. This is transaction ID, comma, this is product ID, sales date, product ID, sales date, and sales amount. Okay. So table is transaction ID, product ID, sales date, and sales amount. What you have to find out is the cumulative sales, sum of sales amount for each of this product ID. So suppose product ID is 1 and 2, right? So 1 and 2 are the distinct product IDs. You have to find out the cumulative sales amount by sales date, like ordered by sales date. So if you also want the like result table, I'll paste that up here so that it's clear. Okay. So you have transaction ID, you have product ID 1111 and 22. It's ordered by your sales date. And then you have sales amount and cumulative sum. So 100, 150, 120 and 90. So 100 plus 150 goes 250. And likewise, it's accumulating it, like the cumulative sum of it. Okay.
Okay. Means the order of the transaction ID will not change.
Yeah, it won't. I mean, that will change because you will order by product ID, right? So that is fine. I mean, your output table, if you see, it's 124635, right? So that can change. Your transaction ID does not matter. So what you have to order by is product ID and sales date. So one thing you have to keep in mind here is while, I mean, the output file, if you see, and the result file that you see here, right?
Yeah.
I mean, the table that you see here, you have to keep in mind this condition here, okay? The cumulative sum should reset to 0 whenever a new product ID is encountered. So if you see here on the first row, it's 100, right? For product ID 1 and product ID 1, it's 150. So your cumulative sum is 100 and 250, right? But while it comes to the third row, you see your product ID changing, right? So for for your third row, if you see, your cumulative sum is not 250 plus 120. So it has reset itself. So it has reset to 0. So
Yeah, I
while
think
it comes to 1,
that function will be used on this transaction ID. I think.
yeah, try it out.
Yeah, I think it is done. Could you please check?
Yeah, but I'm not sure that lag will work. Can you explain this? Because your CT would give you transaction ID, product ID, sales date, and lag of transaction ID, right, over product ID. So how does that work?
Here,
And
here like I created this common table expression for like let me add here for the output of this common table expression.
hmm,
Let's see, and here it will be 0, and then after that, I think here it will be 1, and again,
not zero, that will be null.
yeah, that will be null.
Yeah, null, one,
Sorry, null,
uh,
and then
one.
it will be 1, and again 1.
It won't give after null. How will it give one? Yeah, one. So for one, it will give null. For two, it will give one. For four, it will give three.
Like here, the first it will give null, and then it will give 1,
Hmm.
and after that again it will give
Then
2. Yeah, it will not work here. For that we have to do some different types of. We have to use lag in a different way.
no, you actually don't need to use lag. Okay, let me paste the solution here. Okay, I mean, you can go over it later. So what you need is sum over sales amount, right? Rolling sum over sales amount, and you need to change it by product ID. So your partition column is product ID. You need to order by obviously sales date, right? Then the catch over here is this part. If you see, so what you need to find out is rows between unbounded preceding and current row. So wherever your sum of sales amount has been last calculated over the product ID, the sum should be calculated from there till the current row. So this is the syntax that will solve it, and that will be your cumulative sum. And then obviously you do from sales order by, that is so normal. So yeah, but this is exactly what was missing. But I mean, you can go and read about this. You will find out. So what is unbounded preceding and what is current row? So current row is basically wherever your cursor is right now, right? Is your current row, and your unbounded preceding is it sums over the rows between your unbounded precedent. So your last bounded, like suppose 1 and 1 were your last product ID partition, right? So your last cursor was here, and then you went here to do a sum partition. So it will just do the 200 partition. It will cut off the last unbounded precedents. So that was the meaning of this specific. But yeah, fine. That's fine. You tried. Uh, okay, I think that's all the question that I have from my side. Do you have anything that you want to clarify or you want to?
Okay, we can like can you use anything other than this rules between unbounded preceding and current rules in this?
Yeah, you can. You can. I mean, you can do a normal solution also, which is without using a window function. But of course, it takes a little bit more time. So when the data is bigger size, so I pasted that solution also. You can go through it, but yeah, there's nothing to explain here. It's a subquery kind of operation, right? So you have sum of sales amount and you do a self join here. So self joining is also a way to do it.
Yeah, yeah, it is. It will also work in self-join.
Yeah, yeah. So like basically you will find out if your sales date is less than the current sales date, and you do a like by product ID whenever this matches. you keep the cumulative sum, or else you don't do it. So yeah, that is also a way to do it. I mean, obviously there are different ways to do it. You can even do it by, I think, grouping. Like, I'm not really sure. Like, I also have to try it out. But yeah, it might be possible to grouping also, because as product IDs are there, you can group and create different CTs to get the cumulative answer, and then you could union it all as it will have the same structure, right? So that could also be an approach. But I mean, as we look for the most approach, that could take the minimum amount of time, and as you do CTs also, it also takes away some temporary amount of space also, right? So if we can avoid all these things, obviously we have a optimized solution, because we are not talking about data sets that are 100 or 200 MB, right? If we are working on data that are at, gigabytes of level and or terabytes of level, that is when we get that optimized performance. Or if you pass in this SQL query inside spark.sql command, and it's running in your Databricks, so that is where you gain the performance. So that is exactly where you need to kind of find ways to write more optimized queries, but that's fine. Okay.
Okay, whenever I have
Uh,
understood that this two approach will be good for that. While using common table expression, it will be time consuming and more complex.
yeah, even the third approach, if you see, it uses a subquery, right? Your subqueries are also slower. Subqueries or joins, if you see, are also expensive operations. So
Yeah.
here a window function is actually really faster. And if you use with your window function, if you use unbounded precedence, so like it does without forming a CT or a subquery or a join. So that's why it's faster. So no worries. So just a short feedback also, you should like really revise your like theoretical questions, and also go through the, like, in your company also, while you work, my suggestion would be try to get to know the business use case that you're working for, and what impact you are putting onto the business while you are doing even a minor on-prem to cloud migration, just to you could write in your CV in a better way, like you did, and for what you did. So someone reading the CV will not only have the visibility that what tech stack you used and what ETLs you performed, will also have the visibility as to what impact you created to their business, like to Cognizant business, like how did you kind of impact their clientele. So that is what a lot of interviewers will also look for in a real interview experience.
Okay. Definitely, I will go through all that.
Sure, sure. Okay, that's all from my side.